presentation, memory recall and memory building from kinematics point of view will be discussed. Uh, this is the basis for the brain functioning uh, in general. Uh, Memory units uh, in the long-term structure uh, will be established in a fractal structuring. What is the fractal structure? A tree is a fractal shape. Leaves are similar, smaller branches are like the big branches in patterns of the dividing. If consider curved shape of the water edges in a beach, where you are in the beach, and then watching these curvatures from airplane, and then watching the same pattern from space, uh, all will look similar to each other. This is a fractal pattern. If you look at child's playing behavior, then uh, you will see very similarity with the ways that colleagues they treat each other sometimes in workplaces, and you see in the higher levels, even a politician, they resolve conflict issues in the same way, in a very childish way. You can see similarity in all these behaviors. We also categorize people based on their behavior characteristics. Feelings are originated from few very basic types of the fear. Types of the emotion like fear, aggression, disgust, and possession. Then each of these basic feeling will expand to more sophisticated ones, and subdivision can be continued to much detail, and even you will see the advanced feeling similar to that. Similarity in reasoning and skill algorithms can be expanded in the same way from very basic tasks and shapes to very complicated ones. Anyway, in general, spatial similarity, or we can say self-similarity, form a fractal structure like a tree, like the structure of the memory units in each area of the cortex, and temporal self-similarity, they form attractor streamlines when they are regulated, like similar patterns of the water streams in a river, or similar behaviors, or similar strain energy streamlines over the cortex. As already told, memory units are stored in fractal structure. Different memory units employ different structuring by local connection, density, and configuration, as well as size. Local connection, density, and configuration, as well as size, is based on limbic cortex communications and functional connectivity over the cortex at that location. So based on the cortico-cortex communication, those encode static local memory units like the site for names, numbers, colors, signs, alphabet, and so on. This information in memory units uh, are located over parietal cortex uh, in different they are different from the encoded static information like distances, addresses, faces, shapes, and so on over the temporal cortex. They are also different from encoded dynamic information like speed, verb, episodic, autobiographic memory units in the hippocampus. And all the above mentioned memory units are different from emotion memory units like the site for fear, aggression, and other basic memory, uh, basic emotion memories, and similar to that for the advanced ones. Of course, the basic feelings have a site for memory units in the amygdala, and the advanced feeling memory units have uh, site for memory units over the prefrontal cortex. Finally, all the above mentioned location for memory units, different memory units, is different for procedural and skill memory units, which are located over the prefrontal cortex, premotor area, and finally motor area that submit how to act. In general, if you want to categorize different areas for different types of the memory units, we have sensory brain, which include parietal, occipital, temporal lobes. Uh, this section of the brain uh, encode information in memory units uh, in over the parietal cortex as well as in medial temporal cortex for static shapes or layouts or faces, names, and so on, as well as uh, addresses and so on. The second one is emotional brain, which is the limbic system. It is different from the memory units in this location, are different from those in sensory brain. They are location for short-term memory in hippocampus and feeling memory, basic feeling memory in the amygdala. The third section of the brain is the motor brain or frontal lobe. Uh, Memory units over the prefrontal cortex are different from those in sensory brain and emotion brain. This type of the memory units are called procedural or skills or algorithm. Uh, these are functional, which actually combine the the memory units that receive from sensory brain and emotion brain. They combine that in the procedural memory units or skill unit and so on. And they are located over the prefrontal cortex. A cortex area contains various memory unit sizes depending on how it is activated by radial and horizontal excitation. Radial from the limbic system and horizontal from other areas of the cortex. Different memory units will retrieve by different type of activation based on the strain energy wave that cross those memory units. Similarity between memory units in one area to each other is much more than other areas. Those fractality degree uh, is high in each area rather than between areas. It is good to say that the memory units in the location are symbols of each other. Especially we notice that in dreams, it means that they have some similar features or dimensions in share. Looking at them in lower scale, they may seem very different. However, if we look at them from a higher level, they seem very similar. And this is the meaning of fractal structures. This is very important in dreams that we see characters replace each other. We see ourselves as another person or even as an animal because of fractal property of the memory units may arouse the different feeling by activation. I mean that the different trail of the memory units will arouse different feeling through activation. More thematic dreams or thoughts are those which are excited by localized radial excitation from the limbic components, but more emotional uh, are those type of the dreams and thoughts that their streamlines are more random and wider in surface. Metaphoric similarity of two different behaviors or events in waking speech and dreams as self-talks, they reflect the same pattern of variation in chains and trails of memory units which excite. In language of kinematics, when stress straining streams and kinetic strain carrier waves which cycle around the cortex, uh, they form the strain energy streamlines. They can form a laminar shape of the streamlines or a scattered and turbulent currents pattern. If more thematic, more focused, but if more emotional, the streamlines are more random and spread. over this different areas and in wider range. May number of the emotion types and number of the cortex areas are very related to each other. Uh, More strain exchanges between the limbic system and a specific cortex area will arouse a specific feeling uh, or type of the feelings. It indicates that connectivity configuration in amygdala and the fractal structuring of memory units over the cortex are tightly connected. The role of hippocampal and Papez lobes in emotion bearing to generate a dream or a relaxed thought. The role of this limbic system, hippocampal and Papez lobes, is to regulate the streamlines, regulate them in by high regulation in laminar way or uh, low regulation in turbulent way of the strain energy streamlines. Highly disturbed and irregular strain energy streamlines will not fit to the prefrontal cortex memory units structuring. Uh, it means that the procedural and skill memories are in conflict with the emotional memories. Therefore, uh, in high emotional case and more disturbed streamlines over the cortex, the strains will float as emotion explosion into the motor area in waking. In dream case, maybe they appear as night dreams. In dreaming sleep, the process is introversion, and instead of exploding out, the irregular patterns seek to fit uh, to each other in a regular structure of long-term memory. Uh, they are seeking to arrive in a strain balance together. Those short-term memory components like seems like eddies that are settled in some memory motifs, and in the opposite side, long-term structure, long-term memory structure, it changes itself to fit the new short-term memory was not occurred before. Uh, Memories consolidate after experiencing events and thoughts, but uh, those memories which they have had a strong short-term memory. The weak ones normally we erase very quickly. Those experiences will spread in components and consolidate as memory units over different cortex area accompanying related streamlines, which they are referred as theme, and radial excitation as they are referred by emotion. Memory unit consolidation happens in low kinetic strain energy states. It means that during the relaxed waking, a nap, or most effectively in sleep. In the next slide, we will see that memory recall is opposite to memory consolidation and happens when there is high kinetic strain carrier wave to pick up the related memory units in order to form a short-term memory. The order of the components in the short-term memory is according to the sequence of areas it follows from the parietal to temporal to hippocampal formation, and the order is according to the type of the memory units, in other words. We will see the same order in language grammar, and this confirms the compatibility of the language generation with the kinematics of the brain activity theory. Uh, you know that the question of the uh, language grammar coming from the or based on the thoughts is a debate that has been long discussed about, and still it is under discussion. But the theory of the kinematics of brain activity confirms that they are very and tightly connected. Opposite to memory consolidation, memory recall is possible by activation of the related neural connectivity the, or memory unit. How a neural assembly will be activated. Uh, you know that a neural assembly is the location for a memory unit. It activates by addition and expel of a certain strain package. How much and in which connectivity configuration the strain package will evoke, it depends on the location, viscoelasticity property, and strain storage module. What this exchange of a strain package happens to activate the memory unit when resonation between vertical oscillation and strain carrier wave circulation rate will happen in the location. In a location where several memory motifs are located that each convey a symbolic meaning of each other, thus the size and kinematic of the exchanging strain package will determine which motif has more chance to be activated. In other words, shifting between motifs depends on the strain carrier wave level and amount of the strain package that exchange vertically within the neural column that contains the memory unit. Now I try to explain the relation of the similar memory units in location and a chance of being recalled for one of them. In physics, electrons around nucleus of an atom jump between energy levels or in orbits to lower or higher orbit depending on the amount of the energy it receives or dispatch. The same concept is used in kinematics of brain activity for switching between recall of one memory unit to another memory unit as symbols of each other. In dreaming sleep, a strain carrier wave is emerged by releasing strain residuals. It has low kinematics. Therefore, the recalling memory layer switches between lowest cortex layers. In uh, it answers the question that why dreams happen in pictorial images mostly, and rarely sounds as well. The theory describes that in low strain wave kinetics, only the lowest layer of the memory motifs, which are sensory or uh, pictorial shapes, are accessible. The upper or more complicated memory motifs are uh, or higher uh, complicated motifs are accessible in higher kinematic way during waking, and most complicated only in focused waking. We can example any of the memory units in the same location with another motif as symbols, but this is limited to the brain state, wider range of the replacement in waking, but very limited range in dreaming sleep. Uh, as a note, memory motifs in a cortex location have been encoded in lower layers of the 5 and 6. Memory motifs of higher abstraction cover largely cortex columns up to the uh, area section, which the memory motif is located in. It is also to be noted that the memory motifs in the right brain is more basic, and in the left brain is more complicated and complex. For example, the painting or pictures, mostly they are created in the right brain as art, but mathematics and logic functions are processed in the left brain as scientific tasks. Generation of a dream are taught by connecting memory motifs that are recalled in sequence. Connecting memory strain packages along strain energy streamlines will emerge brain activity in shape of a dream when strain energy is of low kinematics, or thought when strain energy is of high kinematics. A dream is emerged by joining of the memory units that carry a strain load package, and this central image of emotion, uh, which resources from the limbic system, either hippocampus or amygdala, or both of them, uh, they together emerge the dream. For generation of the thought, it is more complicated and not a subject to discuss here. How streamlines that connect memory units are emerged? There are two properties for streamlines that connect memory units to form a dream or a thought. Those are team uh, that are formed by the hippocampal formation, and emotion which are dictated from the amygdala, or in case of the thoughts from uh, somewhere like the premotor area in the prefrontal cortex. Streamlines in linear viscoelastic limit are non-emotional and merely they are, or more they are kinematic. Streamlines in non-linear viscoelastic limit are emotional. A certain integration of the theme and emotion which is attached to it, together they form a stream bundle. Stream bundle is structure streamline in a net. Uh, they form together a strain energy fragment or activity pathway. These are a blended of the static and dynamic components of the memory units. A narrower band of the stream bundle conduct a less emotional generating activity, while a streamline wider band emerge a more emotional activity. Emitting of varying external and internal inputs mixture to the cortex layers to form a brain activity. Stream bundles become irregular and higher in emotion content as much as they lose kinetic energy. More strongly structured streamlines in a stream bundle will base a more rational pathway of activity generation. In opposite, a loose structure streamline back in an emotional activity. A high emotional activity will save the brain tissues from damage and rupturing by popping up strains into motor output area in waking and as nightmares in sleep. Uh, the amygdala has frequent straight connection with the cortex, but thalamus is the most important gate for input emissions to the cortex as well. It categorizes relevant inputs to specific areas. Thalamus is the main gateway not only for sensory and motor exchanges through the sensory channels, but some of its parts or nucleus for the uh, internally produced inputs are involved. The latter part or the parts of the thalamus for internal produced inputs uh, are involved in dreaming formation especially. In short, thalamus play an important role in motor output, sensory information from body, including face and exchange of information between cortex and the limbic system, depending on the state of the brain and activated processing pathway. Information is transferred by means of strain packages regulated by the thalamus that activate uh, certain connectivity configuration of memory units over the cortex. Sensory channels receive information from a stimulus and pass that information on to the thalamus to be dispatched to the to a cerebral cortex area. Thalamus role in radial exchange of input information between the limbic system and inner brain with the cortex. The thalamus has two anterior and posterior poles and four medial, lateral, superior, and inferior surfaces. Each pole or surface connects differently between the cortex and the limbic system as well as to the brain stem. The lateral region of the superior surface has frequent connection with the prefrontal cortex and has role in regulation of emotion uh, by converting immediate basic emotion to delaying advanced emotions. Touch sensory information through the related receptors initiate enriching recycle strain carrier waves through the anterior or ventral spinothalamic tract and the lateral spinothalamic tracts. They carry most basic emotion form of information about pain, hot or cold, temperature, when the area is overstrained by related stimuli. The thalamus cingulate tract from limbic to cingulate cortex to parietal cortex loop is the fundamental activity pathway in the brain. The main role of the thalamus cingulate is radial submission of inputs, including amygdala discharges to circular strain carrier wave streams through cingulate cortex between its anterior to posterior. The congulate cortex has a microstructure that it may behave more than a simple bundle of tracks. It may function like an association area and have a role of strain conducting as well as storing information to some extent. It is important to say that each neural part of the brain have both properties of strain storing as memory and strain energy conduction as activity current, like generating thought or dream. Uh, some are excellent, some parts of the brain are excellent in memory storing, like association area and nuclei. Some are excellent in conducting, uh, but less in memory aspect, like tracts and fibers. All brain activity pathways include variety combination of the components with both strain memory and conducting properties. For example, the hippocampal formation and amygdala in the limbic system have the most important role in both memory recall and memory building, but connecting tissues and uh, backing strain traveling as strain bundles over the cortex. These streamlines over the cortex, they determine theme as receive information from hippocampus and randomness of the streamlines structuring from the amygdala. Thalamus and hippocampal formation loops importance in memory building and memory recall. In general, streamline formation connect memory units. Hippocampal system adds a time dimension to a static coagulated fact memory units taken from the sensory brain locations. Uh, it forms a short-term memory. Similarly, anterior thalamic nucleus will add the time dimension by segregation of emotion from theme dimension to the observed activity which comes from sensory brain. Uh, regularity and irregularity of streamlines over the cortex is strongly connected to radial and circular streamlines, streams, strain streams, separated in the limbic system for components, especially the in the hippocampus, amygdala, and thalamus for different thematic, emotional, and category type of information. The hypothalamus is also important for mediating to convey the body inputs. For dream generation process, the limbic components and the sensory brain back the pathway. For thought generation, the prefrontal cortex pathways will add to the above basic package and pathway to involve working memory also in activity for information. The anterior thalamus interface with the cingulate cortex is very important to construct the basic brain processing pathways. The site of thalamus cingulate tract conduct a combination of the hippocampal and Papez lobe messages from the limbic system. This combination of the messages radially bombard the cortex areas to activate memory units in series to generate a brain activity like a dream or a thought, relaxed thought, of course. This pathway include areas 24, 33, 32 of the cortex areas, and in the posterior cingulate cortex include area number 29 to complete the basic brain activity pathway. We already discussed internal limbic system communication between hippocampal and Papez lobes, which add time dimension to brain activities. The Papez circuit communication with the hippocampal formation before submitting signal information signal to the anterior thalamus nuclei. The anterior thalamic nuclei has a role in episodic memory by exciting related memory units over the cortex and linking them by a time sequence. In this formation, hippocampal and the amygdala has got the main role. Recall of non-declarative memories, including which include facts and episodic memories. They do not need the prefrontal cortex in their loops, in their pathways, but when they recall a part of the working memory, they to generate a thought, anterior thalamus nuclei will support communication with the prefrontal cortex as well in that case, which is of course is not in the scope of this study. And it is very important that cingulate Congulate cortex, including its anterior section, have got two layers. Anterior congulate cortex itself has got two layers of ventral and dorsal. The separated layers segregate the basic the brain activity pathways from more advanced ones, uh, which include the basic one, basic pathway include limbic, ventral, thematic, congulate, parietal cortex, from the limbic, dorsal, prefrontal, parietal emotional pathways. Sorry for all these complications, but anyway, these two layers, they segregate two different basic and advanced pathways of the brain activities in medial scale, of course. Congulate cortex is the loop for the brain activities. It's very essential in recall and consolidation of the of memories. The outer layer will be structured with more complicated cognitive pathways because it has more communication with the prefrontal cortex, especially uh, the part up to perimotor area, uh, starting from orbitofrontal area in the frontal lobe. The congulate cortex recycle is the recycling part of memory recall loops. The congulate cortex recycles strain carrier waves in parallel to the frontal lobes, which are advanced lobes. This circulation is from inferior temporal cortex to the back to the parietal cortex through its anterior part. It may save kind of the memory units that resonate with recycling strain energy flow through it, or in other words, the whole short memory of for a while, for a duration. Please be noted that short-term memory lasts for seconds only to complete the brain activity. Uh, Having the short memory available for a longer period, up to few days, it is the congulate cortex memorizing process that help to elongate that period. The reasoning pathway is not included in the present study scope, maybe in later. But just to touch it, the reasoning pathways over the outer cortex layers will not activate in sleep except the learned material during the day, which they should be build memory units over the cortex, over the prefrontal cortex. Inner layers, the inner layers of 5 and 6, they are the size for the long-term memory units, and these memory units over the prefrontal or frontal lobe as a whole consolidate procedural and skill type of the memories. These memories will appear in story-like scenarios in dreams, like the normal events dream or episodic events uh, that we have normally in short-term memory of the dreams. The recycling produce concept in learning or concluding in waking uh, through the pathways of the reasoning ways or routes. It is supported by the conceptual inputs that recycle in waking to the parietal complex. They will be saved as a temporal input. They are like emotional input that will remain confined but activated uh, in the sensory brain. Similarly happens for the conceptual inputs, and they release in low kinematic strain waves states in sleep. As I told, in high kinematic strain waves state, it is like the water under the high pressure of the gas. The gas will be dissolved more in the water, but when the kinematic strain energy will reduce and it is low in the sleep states, then this dissolved temporary memories will be evaporate or will come to a strain energy circulation again to generate, and they generate the short-term memory of the dreams. Those uh, non-declarative memory units means algorithmic over the frontal lobe, including prefrontal cortex, premotor, and motor areas. The procedure for memory building over those areas is almost similar to uh, uh, the what happening for declarative memories of the facts and episodic over the sensory brain, except uh, the, the, the temporary the strains of the conceptual produce over prefrontal cortex will be stored in the parietal cortex, middle section of that, and these confined strains will release during the sleep, and in circulation they help to support the consolidation of related non-declarative memories. As a summary, the inner layer of congulate cortex pathway is the memory recall pathway, recalling memories by exciting the strain stream uh, streamlines over the cortex for the team aspect. Uh, the hippocampus is involved, and this team will with the episode the temporal character will collect memory units all over the sensory loops. This pathway in the reverse functioning consolidate memory of the streamlines in the within the hippocampus by the exciting memory units over the cortex, and they're emitting the fine strains to the back to the hippocampus. By the above forces, memory recall and memory building can be described from a kinematic point of view. As you see, we are uh, getting to higher level of the speciality in the theory of the kinematics of brain activities step by step. We are again in end part of the Dreamium 10-4. Please do not forget to send your comments and questions to moos.dini@gmail.com. Thank you for watching.